Today I'm going to demonstrate how to use the IR HeliAutoPilot program together with the USB IR toy to analyze and decode the infrared protocol used by this infrared helicopter from this remote. So as you can see, this remote is an infrared remote. You can see the LEDs in there, and the helicopter has a sensor down there, an infrared sensor. And this is the USB IR toy from Dangerous Prototypes. It has a microprocessor, a microcontroller, an infrared receiver, an infrared emitter, an LED, and it connects to your computer using the USB port. And this program is the program that communicates through the USB IR toy to the helicopter and controls it. But before you can control it, you have to decode and decipher the protocol used by the remote. So we're going to connect using the USB port, and here it shows us a serial port. In this case it's COM5. We're going to go to the tab called Read Infrared, Read IR, which is going to tell us what information we're receiving from the USB IR toy. So I'm going to connect, I'm going to click Open, and I'm expecting a confirmation in the way of a code from the IR toy to indicate they're in the right place, and I did not receive it, so I'm going to close and open again, and this time I got it. So this is the hexadecimal representation of the ASCII codes for S02, and the S stands for sampling. We're in sampling mode, and in sampling mode we can receive infrared signals and we can also send them. So I'm going to clear the buffer, I'm going to turn on the remote, and we're going to see what we receive from the remote. So you see immediately the LED goes on and we have information here. I'm going to stop this and we're going to see this information. I'm going to show you what we just got from the remote. I'm going to copy this into Notepad just to show you what it is that we just got. And basically it's a series of bytes, and each pair of bytes represent a pulse, a high pulse and a low pulse, an on pulse and an off pulse. So, and the numbers represent the time of the pulse. So for example, this one is a very long pulse, you can see in hexadecimal format, and that one is followed by a bunch of small pulses. But again, every once in a while we get a long pulse. So the long pulse is basically a pulse between packets or frame. So the remote is sending the same frame repeatedly to the helicopter, and we can see the end of the frame just by detecting those long pulses. So as I'm doing here, I'm separating the frames, and you can see how long each frame is. They're all the same length, and they basically should be the same information because all the while we didn't move the control too much. So all these packets should be the same. Now it is possible to take this and analyze it like this, but it would be very tedious. The hexadecimal representation doesn't really help us, and we'll have to work a lot to decipher it that way. Instead, we can use the IR HeliAutoPilot to read the frames for us. So how it works is we have a threshold here, a pulse, that whenever the pulse is longer than 5 milliseconds in this case, he considers that the end of the frame, and the next thing that comes is going to be a new frame. So he's going to show us that frame by frame. So we're going to go and set it into frame mode. Let's read the frames now instead of the raw data, and let's push on the throttle. Now you see the information comes in a different way. These are decimal numbers, this is not hexadecimal, and the high means it's a high pulse, an on pulse, and the L means it's a low pulse, an off pulse, an off signal. And the numbers is the time in microseconds of that pulse, so the length of the pulse in microseconds. The precision of the IR toy is about plus or minus 21.3 microseconds. So that's why you see a lot of jumping here back and forth between the number, even though we're receiving the same information from the remote. It is actually very sensitive. If you just move this a little bit, you're going to see big changes in all the numbers. So the distance and the position and every obstacle affects the length of the signal. But the protocol that the helicopter uses is very tolerant to all these variations in frequency, in length, as long as you follow the basic construction of the frames, you are okay. So in this case, these numbers move too much, and we need to round them a little bit to make them easier to understand. So we have this round field, and we can round by tens. You still see a lot of movement, so let's round by 100. Now it's more steady. Now you see we have 800s and 400s, but still there's some movement up here. And in this case, we've already detected that we have short pulses and long pulses. So our short pulses are approximately 400, and our long pulses are between 700 and 800. So in this case, the easier thing to do is just to round by 400s, and that way we avoid all the flickering, and now we have a steady signal. So you see 400s and 800s. So what we have done is called finding the pulse. We already know our pulses. We have short pulses of around 400, long pulses of approximately 800 microseconds, and we have high pulses and low pulses. You see, if I change the throttle, you can see how those pulses change, and we can use this to analyze. So now that we know our pulses, we need to determine our ones and zeros. So every frame at the beginning is a little bit different, because that's the beginning of the frame marker, and that indicates that the frame is coming along. So we should ignore the beginning of the frame and concentrate on the rest of the signal. So you can see here that we have a pattern repeating, that every time we find an 800 high, it's followed by an 800 low. So long pulse high, long pulse low. And we can just guess or make a conjecture. It's, deciphering, the protocol is a lot of trial and error and guesswork. So we can assume that that would be probably a 1. So I'm going to take that pattern and I'm going to copy it to the replace field. And I'm going to put a column, and I'm going to replace that pattern for ones. So every time he finds that, he turns it into a 1. And I'm going to do the same thing for the next pattern, which is a short pulse followed by a short pulse. So I'm going to assume that's a 0. I'm going to place that pattern here. I'm going to replace for zeros, and you see already how we have converted most of the information into ones and zeros. So like I said before, the beginning of the frame, it's always a little different. It's a marker indicating that that's a new frame. And so we're going to take that pattern too, and we're going to basically erase it. So between replacement patterns, I use semicolon. Semicolon, I place a pattern and I replace with nothing in this case. I still have the end marker, the end of the frame marker. I'm going to remove that too, doing the same procedure, just replacing it with nothing. And there you go. We have now only ones and zeros. This is what I call the payload. This is just pure information. And you can see as I change the throttle, the ones and zeros change. And that we made the assumption that 800 high meant it was a 1. And we can confirm that that's so, because if we go up, you can see the numbers go up. If we go down, we find more zeros, and that means our assumption was correct. But we can also now do a test. So I'm going to put a pattern here. I'm going to turn it off, and he's going to keep this pattern here, and I'm going to copy that. But before we do that, sorry, I need to enter the protocol that we just discovered, our short pulses and long pulses. We're going to enter that information into here. So we said 2 long pulses is a 1, a high pulse, a high long pulse, and a high low pulse is a 1. Here I don't specify the H or the L because they always alternate. 2 short pulses is a 0. And notice as I type on here on the right side, we get the hexadecimal representation on bytes that is going to be sent to the helicopter. So those are 1s and 0s, and our initial frame is 800, 400, and 800, 400. So long, short, and we always end with a long pulse. So that's our infrared protocol in terms of 1s and 0s and pulses. Now, like I said before, we're going to take this frame and we're going to copy this information into the helicopter protocol tab, the data field. I'm going to paste it here, and look what happened. Did you notice that? I'm going to do it again. As I enter information here, the IR stream gets filled with the hexadecimal representation of that information according to our IR protocol that we just established. So let me show you. If I type here, the IR stream down here gets updated immediately with the change I make. So I'm going to again paste the payload the frame that we read from here, and here comes the test. We're going to test it. We're going to send this information to the helicopter. So we're going to turn on the helicopter now. The helicopter is on. I'm going to send just 1 frame. Here we go. Yeah, that's good confirmation. It works. And notice I just sent 1 frame and the helicopter was spinning for about 2 or 3 seconds. I can also send continuous frames every 100 milliseconds, and it's going to be spinning until I stop it. So I stop it now. Notice how long it goes. Remember in the last frame. So now we have confirmation. This is our test. We have confirmation that our infrared protocol, using even the 800 and 400, which is not exactly the number we're getting, it's still valid. It still works. Like I said, the helicopter is very tolerant of variations in the protocol. For example, you can notice here that the packet size is 37.9 milliseconds, as it is defined with this protocol. But what we were reading was a little bit shorter. Let me turn the reading again. I'm gonna turn on the remote, and so we're reading the frames. And actually, this packet, I don't know if it's the same packet, but we can copy this packet from here to here, just to make sure it's the same. I think it's the same. So this one is 38.7 milliseconds, but what we're reading is 35.8. So our protocol is not exactly, it's not precise, but it's good enough for the helicopter. So he likes it that way. So now that we have determined our 1s and 0s, and we're happy with that, we need to establish which parts of the protocol of the packet correspond to each one of the controls. So the best way to do that is just to move the control along. I'm going to push the throttle here, and you can see where I put my cursor. That's exactly where the throttle changes. So if we count, we can see the first 8 bits are changing when I change the protocol. So I'm going to insert a space there, 8. I'm going to insert 3 spaces to isolate that, to make it more visible, so you can see how nice it looks now. That's the throttle. But we can also see that on the right side we also have some movement. As I move along on the left, the throttle, the right side moves as well, and that would be our checksum. So if we count the bits again, that would be in the position 24. I'm going to insert some spaces here, and notice I put it in descending order. That way I don't have to count the spaces, because I'm inserting the spaces to the left later, after I insert the spaces more to the right, if I do it in descending order as I'm doing now. So now we have isolated the throttle and the checksum. Let's do left and right. So if I change left and right, I can see that these are the values that change. We have 1s, and then we go all the way down to 0s. So that's actually our position 16. I'm inserting 3 spaces. Now we're going to do forward and back. Forward, back, that's our position 18. And this actually has a control for the light. So if I click once, it goes on, goes off. You can see that's this bit. So that would be in position 17. So I'm going to insert it right here in descending order to isolate. And the other part is the channel. So if I switch from A to B to C, you can see there are 2 bits that change. One is this one and the other one is this one. So I need to insert one more in position 9. And now, we have deciphered our protocol. We have analyzed it. We're going to save this information. I don't want to lose this information here. And in a following video, I'm going to show you how to program this protocol into the system so that you can send and control the commands using these controls directly from the HeliAutoPilot. But for now, we're gonna just do with this one frame that we have. We're gonna keep sending that, and let's turn this on and fly away.